representative for the online period. All right, here we go. Sometimes I like to break these down into separate graphs, and I like to use different colors. Let's do this. So we have f of x is x squared, but that's only if x is less than or equal to 1. And we have f of x is 3 if x is between 1 and 2, including 2. And we have f of x equals x if x is greater than 2. So basically, we just need to graph y equals x squared. So we already talked about earlier what that looks like, kind of like this graph right here, right? I need to be more careful. I'll be more specific with my points. Sometimes it's important to be accurate, sometimes it's not. This might be one of those times when we want to be accurate. Okay, so I realize I just drew the whole parabola, more or less. If you're writing in pen, I apologize right now, because what does our domain say? We just want x less than or equal to 1. That means we're not including this whole piece right here. We're just doing that one. We're stopping at 1. But it's still a piece of that parabola that we talked about on the previous page, right? Or the previous page with our toolkit functions, our common functions. It's that same parabola, it's just only the part of it that's less than or equal to 1. Okay, now let's go to this one. F of x equals 3, so y equals 3, so that's just a constant flat line. But that's only going to be between 1 and 2. What do you notice about 1? It's not included. Yeah, it's just less. And so therefore, we have at 3, we have an open circle here. You can see my open circle. And then to there, it's just between 1 and 2. What do we have at 2? That's just our cleanup box. We'll be all right. In fact, you know what, to save us time? I guess I'm supposed to have you clean your own spaces, but to be honest, I don't have a fourth period. So it really doesn't matter if I have you guys clean up or not, because no one's going to be using these desks again today, and we can study for things later. So that gives us 10 more minutes. Sound like a plan? If you want to clean stuff, you can. Just saying. Okay. So what does the graph? Oh, I'm done with that one, right? I just need to change back to my colors. So y equals x. So that's our identity function, just that diagonal line. We want to start that greater than 2. So let's think about that for a minute. If I plug in 2 for x, then y also equals 2, correct? Where is that point going to be? At 2, 2. Is it included?
No.
So what do we draw there? Open circle. What does the rest of the graph look like greater than 2 at that point? It's just that diagonal line going this way. Sometimes when I do problems like this, I literally use colored pencils. And I draw in each piece separately with a different color, just kind of lightly. And then go back in over the pieces of the functions that are actually part of our function, like in a black color or something, just to designate. So if you were to have the other pieces of these kind of just sort of if they're in the background, I'm not drawing that very well. Do you know what I mean? To draw them, sometimes it's easier to draw the whole thing and then erase out what you don't know. Okay. Make sense? How are we feeling about graphing piecewise? So the key is understanding all of those toolbox, those common functions, and what those look like, so that you can then graph pieces of them. Okay. Oh, is this all part of 1.2? Jeez. Forgot we had so much to do. We don't have time to finish all this today, do we? It's okay. Technology got the best of us today. Okay, I'm going to go.